Yes, tell me the question.
Basically, assignment number 2, question number 1.
Okay, so that means
The results were declared. Huh? Basically, the question was to find the expected spin value of the ground state of nucleus calcium 2043
hmm,
within the nuclear shell model. Huh?
hmm.
The corrected accepted answer was 5.2. What you have stated there. But what I found that it was 7/2. I did the question. Maybe I am wrong, but I doubt it little bit. No? The
Just a minute.
procedure.
I have to open the question and after that I can say.
Oh, yeah. Thank you.
Question number 2.
Question number 1.
1.
Yeah. Assignment number 2.
Yeah, what is the expected spin value of the ground state of the nucleus
Mm,
9 nitrogen 715 within this nuclear cell model? Is
No,
it
no, no. It wasn't the question. The question was what is the expected spin value of the ground state of nucleus calcium 2043?
715?
The 2043 calcium.
Okay, just a minute. I think
Assignment number 2.
oh, assignment 2. Assignment 2. Okay. I can share my screen so that it will be good.
Yeah.
Just a minute. My screen is visible, right?
Yeah.
Okay. So this is the question, assignment number 2. And
Yeah.
so what is the expected value of the
No, no, no,
ground?
no, 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 ma'am. You are getting it wrong. I said assignment number 2. Now, what was asked in the assignment?
This is the assignment. Like whatever I have taught you or a previous.
No, 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 no. What was the actual assignment?
Okay, 2022 questions you are talking about.
Yeah, yeah. 2022 question, assignment number 2.
Okay, okay,
What the question was? What is the expected spin value of ground state of nucleus calcium 2043?
okay. Within the nuclear shell model.
Yeah,
Okay, so just similar like that one also. I think like
yeah. I got 7/2.
okay,
But the answer you have shown that it is correct was 5/2. But I didn't get 5/2. I did it once, twice, again and again. I get 7/2.
okay, okay. So the nucleus was calcium 2041, right?
2043.
43. Okay.
Yeah,
So that means just a minute. If I write here somewhere, then it will be good.
yeah. Anyway.
Yeah.
Mhm.
It is the question assignment 3, but still I am writing here. No problem on that.
Yeah. Thank you. Thank you. Thank you.
Okay.
Thank
So here
20,
43.
43.
So here basically
Yeah,
what is there? Z equals to 20. Oh, just a minute. So
that is equal to 20 and n is equal to 23.
and n equals to 23, right?
Yeah.
Just a minute.
Mhm.
I have to close my things. So that means for basically n is even not even here. So that means it is a odd. So that means only this portion will give us a neutrino property, nuclear properties. So
Nuclear, exactly.
so n23 is like if I write here 1s2.
1p3 by
Okay, just a minute. 1p3/2. Just a minute. I have a question that assignment already submitted by you or not? Like, if it is not submitted, then it will be bad that I am telling you the result.
no. The results are out. For this assignment, results are out on already.
Okay, then it's fine. So 1s2, 1p3/2, 1p half, 2, then 1d 5/2, 6.
2.
Like here 2,
Yeah.
4, 6, 8. Okay.
14.
I'm not getting any space here. Okay, I'm
Yes.
writing here. So then 2, sorry, 2 is half, 2.
Oh yeah.
So that then
1,
1d 3/2,
3 by 2, 4.
4. So how is it all the things like 2, 4, 6, 8, 14, 14 plus 2, 16, 16 plus 4, 20. And
20.
after that it will be
What if 7 by 2?
1
What if 7 by
half,
2?
7/2, then
2
3.
with 3. Yeah. So what is the J value then?
Yeah. So here what it is asking that spin parity, I think, right?
Yeah, spin only.
Okay, spin parity. So that means if I write only this portion here, 1 7/2.
Yeah, that is
So
okay.
that means 1, 2, 3 nuclear is
3.
there. Neutron, right?
Yeah.
So that means what will be there? This one, and this one.
One.
That's it.
Yeah.
So it's basically these two will give 0,
Yeah.
and this will give us 7/2 is there.
2.
And
Yeah.
f is minus 1 to the power L. So that means
Minus 1 to the odd parity.
SPDF. Okay, so that means
Mhm.
0, 1, 2, 3. That means 3.
Yeah.
That means minus 1. So it should be 7/2 minus. But what is
Yeah,
the
I get it 7 by 2 minus. I get 7 by 2 minus answer. I did it once, twice. But when the results came out, the assignment results came out, they said there is written that your answer is not accepted. It is its parity is 5 by 2.
parity is pi by 2?
Yeah. But I didn't by any means get that answer.
No, like what they are telling that what is the value for that? What is the answer?
What is the expected spin? Spin. Sorry, not parity, spin.
Spin.
Yeah.
Okay, then spin means like whatever it is.
7 by 2 only.
So here J equals to L plus S. So that means L is what here? L is 3. Right?
Mm-hmm.
F.
Yeah.
F plus S, which is like 7/2. Right?
Yeah.
So that means S will be 7/2 minus 3. So that means half.
Mm-hmm.
Is it correct?
No. There is no neither any option of the half. There's the options are 7 by 2, 5 by 2, 1 or 3 by 2.
You are talking about spin, right?
Yeah. What is the expected spin? I will read out the question again. What is the expected spin value of the ground state of nucleus Ca-2043 within the nuclear shell bond? The options are 7 by 2, 5 by 2, 1 and 3 by 2. I get it 7 by 2. But in the results, they have stated it as
7/2 is
incorrect.
basically the J value. Like
Yeah, J value.
total angular momentum value. So J is
Mm-hmm.
basically L plus S. So, okay, let me do one thing. Here, 1, 2, 3 is there. So as a whole, j equals to 7 by 2 and L plus S. L should be, F is there, so that means 0, 1, 2, 3. 3. I think it should be half. Like spin, if I am talking about spin angular momentum, then it should be half. But you are saying that there is no.
There is no option of the half. The first option is 7 by 2, the second option is 5 by 2, the third option is 1, and the fourth option is 3 by 2.
Okay. So.
It is the assignment number 2, which was asked.
Okay, just hold
Or
for a
assignment 2.
minute.
Results are already out.
I will tell in the next week that what is the problem here going on. Okay, sorry.
Basically, as per the as per the calculations, it came out 7 by 2.
Yeah, like if J is there, then 7 by 2 will be there, and if S is asking about, then S will be half.
Yeah. But there is no option of half.
Okay, I will tell you in next week.
Thank,
Okay.
thank.
Sorry, like as per my knowledge, it's like half is there, but okay, let me check if there is any problem. Like I am wrong or something, then I will tell you. Okay.
Thank you. Thank you.
Okay.
Thank you.
So hello everyone. Today is the assignment 3 questions is there. Like it is basically I am telling about something that some of you are talking about that previous present year assignment, but I am not doing here present year assignment. I am doing here not exactly previous year assignment also, but I am just doing here some important question related to your week. Like if week 3 is there, then what will be the important questions for week 3. I am doing like that. It is not like that I am doing the same thing which is given in your present year assignment. So obviously present year assignment will be done by you itself because it's a question like thing, and I am not saying anything about that. But yeah, obviously if there is any question regarding this present year assignment, then you can tell me and I will help. If I will do, then I can help you. So just like that, he was just asking one question for me, so I will tell you in the next week if it is possible. So basically here in that question number 1, week number 3, like just a minute, I have to erase all the things. It's a very fuzzy thing. Okay, I'm erasing all the things. Okay, so what is the question here? The question is the first extracted, like explain the statement, is it right or wrong? The question is like the first extracted state of calcium 2041 is found to have IP 3 by 2 minus, which is explained well within the single particle cell model. So this is the question, like it's a statement, it's not basically a question. The question is basically what is the statement is wrong or right. So coming to the question clearly, the question said that calcium 2041 is there, and we have to say that the first excited state have spin parity 3 by 2 minus or not. So let's calculate here. Calcium 2041 is there, just like the similar thing just right now we have talking about. Z equals to 20 and N equals to 21. So that means if I write here the configuration here, for only N equal to 21 will be there. So that means 1 is half 2, then 1 P 3 by 2 4, then 1 P half 2, then 1 D 5 by 2 6, 2 S half 2, then coming to the next one, 2 S half, then 1 D 3 by 2, 1 D 3 by 2 4, and 1 F 7 by 2 1. Why 1 is there? Because 41 is there. So if 43 will be there, then it will be 3. So like what is the ground state here? The ground state is like 1f 7 by 2. But in this question they are not talking about ground state, they are talking about first excited state. Then if see here there is only one neutron in that ground state. So if I in that ground state, it is ground state. So what will be in first excited state? The first excited state, if I write something here 1f 7 by 2, and just above of that what is there, the thing is 2 p 3 by 2. So if in ground state there the neutron was there, so in that excited state the valence neutron, which is this one can go up to here. So that means in that first excited state the neutron will be in that state. So that means first excited state, I am writing like that. So in that first excited state, what will be the outermost neutron configuration? Shit, just a minute. Okay, so here basically 2p 3 by 2 is the last neutron configuration. Here 1 in that first excited state. So what will be the spin parity for that? Like 3 by 2 is there, so that means 3 by 2 and minus minus 1 to the power 1, so that means minus 1. So 3 by 2 minus will be the spin parity for this state. So what was the question? The question was the first excited state of the calcium 2041 is found to have IP equals to 3 by 2 minus, which is explained well within the single particle cell model. So it's obviously right, because as we already see that the IP for first excited state of calcium 2041 is 3 by 2 minus. So now coming to the second question. The second question is like in the week 3, I think you all have know about the radioactivity, what is basically the radioactivity and what is the expression for radioactive elements. So there is basically in the question number 2 I have a question about the radioactivity. So the question is basically the activity of a sample of radioactive element is found to be 180 per second. If its half-life is 31.58 seconds, the number of parent elements present in the sample now is, then what will be the value of number of parent elements present in the sample? So before going to the answer of that question, I would like to say about some like very similar and very simple explanation of radioactive nucleus. So here just a minute. Here this. Okay, so it's not working. So the radioactive sample has an expression that n equals to n0 e to the power minus lambda t. So what these things are basically, so what is n, what is n0, what is lambda and what is t? Like a radioactive element is basically nothing but an element which can radiate some energy. Like some energy means it can be radiate X-ray, it can be radiate alpha, beta and gamma. So alpha, beta and gamma, 3 types of radiation can be there. So like if our parent nucleus is like, let's say X, Z, A, then after radiation it will be like Y, Z minus, Z minus something or Z plus something, or like there are 3 types of radioactive nuclei. I already told that if alpha particle will be there, then Z minus 2 and A minus 4 will be there, plus alpha will be there, alpha 2 4. So this is for the alpha decay configuration. So that means for that expression, X is our parent nucleus and Y is our daughter nucleus, and alpha is like the outgoing particle here. So if alpha decay will be there, then outgoing particle will be alpha, and if beta decay will be there, then outgoing particle will be beta minus 1 0. So that means it is basically nothing but an electron. It's a beta minus decay. Beta plus decay, then it will be beta plus 1 and 0. So these type of things are there. So and if gamma will be there, gamma has nothing, like gamma is nothing but a photon. So if gamma will be radiative, so that means what, in what condition gamma is radiated here. So if gamma is there, so that means x, let's say z a, it is not writing, x z a, and there will be a star. Star means it's a in excitated state. So gamma will be radiated, so that means what, x will be there, z a. So that means there is nothing. So this one is the for the gamma radiation. So these three types of radiation is there. So basically the expression whatever I have written here, that n equals to n0 e to the power minus lambda t. So what is n0 here? N0 is the number of elements of the parent nucleus. Here I have already told you that x is the parent nucleus and y is the daughter nucleus. So n0 is basically the number of parent nucleus element, and y like after getting decay, what will happen, the x will decay. So x will decay, that means the number of x will be decreased. So that the n after time t, let's say after time t, the number of particles, the number of parent particles will be n, which is not decaying right now. After time t, it is not decaying, it is undecayed. So that means n equals to n0 e to the power minus lambda t, which says that how our radiative element will decay at a time t. And what is lambda? Lambda is basically the decay constant, like how frequently, how fastly the radiative element will decay. So that is basically lambda. So okay, so here the expression is like, for lambda the expression is, I think you all know that 6.693 divided by t half. T half is nothing but the half-life of that parent nucleus. So half-life means like the time at which half of the element will decay. Okay, so like in that question what they are asking about A, which is activity. I am telling here, yes. So activity is like what? The activity, if I just going to say about the definition of activity, then what is activity? The activity is the total decay rate of a sample of one or more radioactive nuclides is known as the activity of that sample. So activity, if I write here A, so that means A is nothing but the decay rate, like how it is decaying. So A is minus dN dt. Okay, so that means if n is there, and we know that n expression that n0 to the power minus lambda t, so that means if I derivative under t, then it with respect to t, then it will be nothing but lambda into n. Like basically it will be like lambda n0 to the power minus lambda t. So n0 to the minus lambda t is an n, so that means lambda into n. So that means the activity has a expression A equals to lambda into n. Now in that question what is given here, the given is like A equals to 180 second inverse and the half-life is given 31.58 second. So if A T half is there, so that means we can find then T half, if T half equals to 31.58 second, then what will be the value of lambda? Lambda is nothing but, where it is, lambda is 0.693 divided by T half. T half means 31.58. So that means the answer will be 0.02194 second inverse. So it is the second inverse because obviously the t is in the denominator here. So what will be the value of n? N like that what is the number of parent nucleus after time, that after the decay rate, like A activity is 190 and T half is 31.58 second, then what will be the value of n like after decaying? So n is like simply a by lambda. So just put value of a is 180 divided by lambda is 0.02194. So that means it has the value 8 to 8, like here 8 to 8 is 0.59. Basically 8 to 8 is 0.59 has no physical meaning here, because the number of elements cannot be in fraction. So that means we have to write the integer, nearest integer value, which is 8203. Like if I write here 8202.5959 means it's like greater than 5, so that means you can write here 8203. So the question was that the number of parent elements present in the sample now. So now means it should be n after taking the value a by lambda, which is nothing but 8202.59, but we are taking the nearest integer value because it's a number, so that's why 8203 will be there. So this is about the second question. Now coming to the third question, here in assignment 3 week number 3 we are going to discuss about let's see 8 questions, but obviously if time permits then we can do 8 questions, otherwise let's see. So in that third question, what is third question? Third question is calcium 2040 undergoes beta decay to scandium 2140 with half-life of 9.435 minutes, starting with a fresh sample of 1000 atoms. Just mention here that 1000 atom. How many parent atoms will be there after 28.305 minutes? And we have to write here the closest integer. As I already told you that the number of particle cannot be in a fraction, so it should be in integer value. So that's why 28.305 minutes. After 28.305 minutes, what will be the value of parent atoms? And we have to write this in closest integer form. So the same expression will be there. It's not written here. Okay. What is there? N equals to n0 e to the power minus lambda t, right? So what is n? The question is that n like we have to find the value of n. N is the number of parent atom after that time. So we have to calculate the value of n. But before that, what is the given here? N0 is given, lambda is given or not, we have to see, and t is given or not, we have to see. So n0 in that expression, what is n0? N0 is 1000 atoms. It's 1000, so that means this one will be not there. So that means 1000 is there. So 1000 atoms is there, and what it is given there, that t is 28.305 minute, and what is there? Half-life, that means t half equals to 9.435 minute. So this three data is given here. So if I put here the expression, in that expression, then n0 is 1000, t is, what is there to t? T is t, what is there? T is 28.305. T is 28.305, and t half is given, so that means lambda I can calculate by the equation 0.693 divided by t half. So if I calculate these things, then lambda will be, I have calculated this one, so lambda will be 0.0734 minute inverse. Okay, so if I put these values here, then what will be the value of n? N equals to 1000 into e to the power minus lambda is 0.0734 into t is 28.305. So if I calculate this value, it is basically near about 1000 into e to the power minus 2.0794. Just it a very simple calculation, and we can write here it's that 125 like it's approximately 125, as I already told you that integer number will be given. So the number of parent nucleus will be 125 in that question. Okay, so here the question was, I can tell you the question again, that calcium undergoes beta decay. Okay, so calcium undergoes beta decay. If I write this expression here, calcium 2040, it will go to scandium 2140 plus beta minus 1 0. Then you can just see that this expression is correct or not, like 21 and minus 1. If I just add these things, then it will be 20, and 40 and 0, so that means it is 40. Okay, so that means the expression nuclear reaction will be like that: calcium 2042 scandium, sorry, why it is like that, 2140 plus beta minus 1 0. So these type of things are there. Fine, and after calculating these things, one can have the value of parent nucleus as 125. Like, so what is the meaning of that? That after t equals to 28.305 minute, we can have 125 parent nucleus undecayed. Okay, so this is for question number 3, and coming to the question number 4. Question number 4 is a little bit, like, it's not exactly very difficult, but it's a little bit tricky. So let's come to the question. The question is, a pure sample of dy66150 contains 100,000 atoms at time t equals to 0. So that means in that equation, in that question, it's given that n0 is 1, 2, 3, 4, 5. 100,000, and it is at a time t equals to 0. T equals to 0 means when the decay will not start yet. It's a t equal to 0 time. Now it radioactive decays 64% to Tb65. Okay. So the question is, it radioactive decays 64% to Tb65 150 and 36% to gadolinium 64 146 through beta plus and alpha decays respectively. Like, as I already told you that that for dy 66 150, if it will decay like beta decay, then what it will be, like something will be there, that means that TB is there, and what is that, 65 and 150 will be there, and what it will be, that beta plus 1 0, that means beta plus decay. And the alpha decay, like if alpha decay will be there, so that means 66 150. If alpha decay will be there, so that means GD Z, just a minute, ZD 64 146 plus alpha 2 4, because 64 plus 2 66 and 146 plus 4 equals to 150. So this type of two type of reaction will be there for dy 66 150, and it is also saying that this expression will be 64% and it will be 36%. Like, if 100 dy will be there, then 64 will decay to Tb, and if 100 dy is there, then 36 will decay into Zd. This is the main this is the main thing for that expression, for that question. Then after 1 minute, the sample contains 5900 atoms of Tb 65 150. The half-life of dy 66 150 is in minutes. Write your answer up to 1 decimal place. So coming to the expression here, see the number of dy atoms at time t equals to 0 is 100,000. It is given in that equation also, in that question also. The number of tb atoms at time t equals to 1 minute is what? 5900. Then what is the basically it means? If I write here somewhere, that as I already told you that if 100 dy was there, after some time 64 will be the number of tb. Okay, but here if I just write it reversely, that 64 atoms will be tb if the parent nucleus was 100. So just do one thing, that 1 atom, then 100 divided by 64, right? Then it is given here that 5900 tb atom is there. So that means what was the initial value of that dy? So that was 100 into 5900 divided by 64. 64. Okay. So this has a expression, and so right now after 1 minute, what will be the value of n dy? It will be obviously 1 0 0 0 0 1 2 3 4 5 1 2 3 4 5, this minus this portion. Why this portion? Because it's already decayed. Like the undecayed thing are there, what 100,000 minus this portion, so which is basically nothing but 90781. And just right now we have to put that n1 dy equals to n0 dy e to the power minus lambda t, and right now it is saying that what is the value of t half. So we can only say the value of t half if I just write lambda, because we know that lambda equals to, where it is, lambda equals to 0.693 divided by t half, right? So that means like if t half is the if lambda I can calculate, that from that t half can be calculated as well. So what will be the lambda here? E to the power minus lambda t, which is n1 dy divided by n0 dy. So what will be the value of that? Like if I calculate lambda, then it will be ln 10000 divided by 90781. Why 90781? Because for here t equals to 1 minute is there, so that means if t equals to 1, that means it's a very simple calculation, and 0.09672 will be the answer for lambda. And if I can find the value of lambda, I can also find the value of t half here, that 0.693 divided by 0.09672, that means 7.17 minute. So this is the t half of that particle, like of that element. The half life of DYA66150 is 7.17 minutes. It's given here. I think it's clear to all. Then coming to the question number 5. Question number 5 is a very simple question. Like radon 222 is a radioactive element with half-life of 5 days. It decays on this element after 1 alpha decay. Sorry, there is a typo here. It will be decay. Okay, whatever it is. So the question is radon 222, but for that question we need some more information, that what is the value of Z here, because if I do the alpha decay here, then that means what will be the value? Like there will be one element which has Z minus 2 and A minus 4. So A minus 4 we can write here that 218 will be there, but what will be the value of Z here? Z minus 2. So what is the value of Z? With that respect I can say that what is the value of Z minus 2. So for radon 86 is Z value is 86. So that means Y will be 84 and 218. Okay, So so that means y will be 84 and 218, but 84 means it has a specific element number which is polonium, so that means polonium 84 218. Right, the question, the answer will be that outgoing particle will be polonium 84 218 and with the outgoing particle as alpha 24. So this is the question for this is the answer for question number 5. It's a very simple question that if alpha decay will be there, then what will be the one alpha decay will be there, then it decays the in which element. So if 2 alpha decay was there, so 2 alpha decay means, let's say radium 86 222. So if 2 alpha decay is there, I'm just telling about a simple question that if 2 alpha is there, so 2 alpha means what? 2 into alpha 2 4. So that means what will be the value of daughter nucleus? It will be y 86 minus 4, that means 82, and 222 minus 8, because 222 minus 4 minus 4, so that means 218 minus 4 214. But what will be the value of y here? The y has z equals to 82, which is nothing but the late. So late 82 214. Fine. This is the question number 5. Now coming to the question number 6. In that question number 6, what is given here? Radium 86 210 alpha decays to polonium 84 206 with a very short half-life. Mass of radium 86 210, polonium 84 206, and the alpha particle are this respectively. Compute the Q value of the reaction in MEV, give up to 1 decimal place. So this is the question. So what will be the answer for that? The question is nothing but, if I write here, radium 86 210 alpha decay, polonium 84 206 plus alpha is there. Basically alpha decay is there, so that means we can write here alpha or we can write here alpha. It's a very similar thing, but we can't write both of these in that equation, so it's a wrong thing. Like if I write here, then it should not be there, and if it is there, so that means it should not be there. So just like that. So this is the expression for alpha decay. So they are telling about that mass of, someone is coming. No, okay. So in that expression, what is given here, the mass of radium, polonium and alpha particle is there. Compute the Q value of the reaction in MEV. Q value is nothing but the value, it has a expression. Q value is nothing but mass of radium minus mass of polonium minus mass of alpha. Like the mass difference between this parent nucleus and the outgoing particles. So this is the Q value of the reaction in MEV. Like no, not in MEV, because all the things are given in U. So we have to consider, we have to convert this U in MEV, as we already know in that previous, I think second, I think assignment number 1, I have mentioned that 1 U equals to 9, 931.5 MeV. So just putting these values, as I already told you what will be the value of Q. Q is M radium, M polonium minus M alpha. So that means M, I have calculated this, that if I just minus this 2 with that M RA, then what will be the value in AMU. So it's 0.56617 U will be there. So if I want to write in MEV, then it will be 0.56617 into 931.5 MeV. So which is nothing but 57.38 MeV. So this is the value of Q value here in that expression, in that calculation. Question, whatever. So this is the sixth question. Now coming to the seventh question. Seventh question said that an element with atomic mass 120. Okay. So let's say that X 120 is there. It alpha decays with Q value. It's given that Q value for the reaction is given 8.2 MeV, and what will be the Y? Y will be obviously 116, because 4, like 120 minus 4, that means 116 will be there. So the an element with atomic mass 120, alpha decays with Q value 8.2 MeV. Here Q value is given 8.2 MeV. The kinetic energy of the alpha particle is what? Up to 2 decimal place I have to write it. So kinetic energy of the alpha particle, like alpha particle has a kinetic energy. It has a expression like this one here. If I write here the expression that Q value is nothing but the alpha particle energy into 1 plus m divided by md. So then what is m and what is md? M is the mass of alpha particle and md is the mass number of daughter particle. So here daughter particle has mass number 116 and m is obviously have 4. So that means if I calculate here, like as we already know what is the value of Q here, Q is 8.2 equals to A into 1 plus 4 by 116. So if I calculate these things, here we can have E equals to 8.2 divided by, like what is there, 120 divided by 116. So which is nothing but, it's given here 7.92 MeV. 7.92 MeV. So this is the value of kinetic energy of alpha particle in this interaction. Find the element with atomic mass 120, alpha decays with Q value 8.2 MeV. Then the kinetic energy of the alpha particle will be in MeV, that's 7.92 MeV. Because the expression is Q equals to E into 1 plus M by capital MD. Then E equals to Q by 1 plus 4 by 116, and solving E equals to 7.92 MeV. So it's for the seventh question. Now coming to the eighth question. Eighth question is a little bit tricky, but obviously not that much tricky. At first we have to read the question first. The question is radium 86203 undergoes alpha decays to polonium 84119. The spin and parity of both the parent and daughter nuclei is found to be 3/2 minus. Okay. Then which of the following are possible values of the relative orbital angular momentum of the alpha particle? So this is the question here. So if it is alpha decay, so that means we have to write at first the expression radium 86203, it will undergoes alpha decay and become polonium 84199. Let's better to write like that. Ra goes to PO plus alpha to 4. This is the similar thing as I have written here in that above expression. So this is the thing here, it is written like it is going here. So what they are telling that they are telling that the spin parity of both the parent and daughter nuclei is found to be 3/2 minus 3/2 minus. Then what will be the value of IP, I think. No. Which of the following are possible values of the relative orbital angular momentum of the alpha particle? Then what will be the value of L for alpha particle? It is given in that expression question, that what will be the value of L. Now coming to the answer part. It's given that IP of radium is 3/2 minus, IP is of polonium is 3/2 minus. But we already know that I equals to IP0 plus L. Like where L is the orbital angular momentum of alpha particle, and for alpha particle the spin part is 0, so that means only J, like J equals to L plus S, so S equals to 0, so that means J equals to L here. So IRA equals to IPO plus L, where L is the orbital angular momentum of alpha particle. Then I can have the values from 3/2 minus 3/2 to 3/2 plus 3/2, because it's a vector sum. Okay. So that means 3/2 minus 3/2 equals to 0 to 3/2 plus 3/2, that means 3. That means allowed values are 0, 1, 2, 3. But there is a but. Like L can have the values of alpha like 0, 1, 2, 3. These 4 values are allowed by the spin, like by the vector sum of that total angular momentum. But there is a constant also. The constant is parity of radium is minus, and parity of polonium is also minus. Sorry. So that means like the parent nucleus has the same parity as the daughter nucleus. So that means we can see that all odd values of L are not allowed here. Like if odd values of if odd values are allowed, like what will be then? Okay, let's say that Ra has a parity -1, parity of polonium is -1. So if parity of alpha, where it is, parity of alpha is let's say -1 to the power 1, that means minus. So as parity is a multiplicative quantum number, so that means what, the outgoing particle has a total parity is -1 into -1, which is positive. But the daughter nucleus has a parity -1, that means odd parity. So that means if parent nucleus has odd parity and the daughter nucleus has even parity, then it will not be a nuclear reaction, because in that nuclear reaction QCD is valid, and QCD obviously says that parity should be conserved in any nuclear like radioactive nuclear reaction. So that means obviously P of alpha will be +1. Why P of alpha is +1? Because if P of alpha is +1, then only we can write +1 into -1, which is -1, which is basically nothing but the daughter nucleus parity. Where it is? Sorry. So as before we have talked about that L of alpha is 0, 1, 2, 3. These all 4 were possible by the orbital angular momentum calculation, but that parity calculation gives us the allowed values for L alpha is only 0 or 2, so that -1 to the power 0 will be positive, which is same as -1 to the power 2. So that means the allowed allowed parity of that particle, of alpha particle, will be 0 and 2. It should not be 1 and 3, because if 1 and 3 will be there, then there would be a multiplication of parity which does not conserve our parity in our nuclear reaction. So this is the answer for that question, that if 3/2 minus 3/2 minus will be daughter and parent nucleus spin parity, then the relative orbital angular momentum of the alpha particle, that means that L value will be 0 and 2, like possible L values are 0 and 2. It should not be there 1 and 3, but still like In orbital angular momentum calculation 0, 1, 2, 3, these four are possible, but as parity is considered here, parity should be conserved in our nuclear reaction, so that the value of the L will be 0 or 2, like possible values of orbital angular momentum of alpha particles should be 0 or 2. So this is the question answer for that last question, which is question number 8. So I have written here that allowed values of relative orbital angular momentum of alpha particle equal to 0 and 2, and correct answer will be A and C. Here A and C is 0 and 2. So this is up to today, and if there is any question, I will answer that question whatever that previous student was asked to me about that calcium 20, 43 spin parity. I will tell about that. So
Okay.
till now, like in that week, if there is any question, then you can just ask me. If my handwriting is not that much good, like I can't write in that tab here, okay, whatever. So if there is any problem, then you can ask.
Ma'am,
Yes.
ma'am, I have a doubt in the one question, which is
Okay.
64% of
Okay.
that.
Yes. It's a little
Uh,
bit tricky question, so just tell me what is the problem.
uh, how we write the 9,000 divided by 64 into 100? That part I
Okay.
has some.
Okay. 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 Sure. Sure. See, as I already mentioned here, yeah, this one is that dy 66 150 to tb 65 150 plus beta plus 10, which is the beta minus dk, and this beta minus dk will be 64% here. Okay, so 64% means what? Like if our parent nucleus has 100 a number of elements, then 64%, like 64 number of element will be decay to tb 60 whatever 65 150. Okay, so this is the meaning for that 64% decay, radioactive decays, and for that gd, sorry, for gd it is 36%. Okay, so 64% and 36% means what? Like as I already told that if 100 particle like parent particle was there, then 64 number of particle will be tb. So just reverse of that. Okay, so the reverse of that means if 64 particle will be produced like tb will be 64 when our parent particle has the value 100. Fine. Now just do one thing. Where should I do? Here. So if 64 is daughter nucleus, then for producing daughter nucleus at 64, our parent nucleus will be 100. So do one thing, that if one particle, like one daughter nucleus is there, then what will be the value of parent nucleus, which is nothing but 100 divided by 64. Now coming to the part that it is given in that equation that after 1 minute the sample contains 5900 TB. So if 5900 TB is there, so after 1 minute what will be the value of parent nucleus? So what will be that? 100 into 5900 divided by 64. So this will be the parent nucleus after 1 minute, because in that question it is written that after 1 minute the sample contains 5900 atoms of Tb 65 150. So then what will be the remaining particle here? The remaining particle after like n1 dy is total value minus this one. So that means which is nothing but 90781. And this can be written as like n equals to n0 e to the power minus lambda t. So n is that one after t equals to 1 minute, and n0 is obviously that 100,000, and t equals to here 1 minute. So from that we can find the value of lambda, and from lambda we can find the value of t half, which is 0.693 divided by.
Okay, ma'am. Thank you, ma'am.
Lambda. So just 64 percentage meaning is that it if 100 will be the parent nucleus, then 64 number of particles will be daughter nucleus after 1 minute. And which one will be that? The daughter nucleus will be TB65150. So this is the main trick of that question here, that 64% to TB and 6% to GD. Here we are not considering about GD anywhere, because in that question there is no mention of GD, like after 1 minute what is the value of GD. It is not like here given. So if it is given there, then we can say that okay, for 36 GD we have to take 100 dy. So just similar thing we should do there. But as here only 64% and TB 65150 data is given there, so that's why we can have only the value of 64 and 5900 into 100 divided by 64, and as a whole what is the value? 100,000 minus 5900 into 100 divided by 64. So and after that the n will be there, and just putting in that expression we can have the value of n equals to n0 to the minus lambda t, and from that lambda equals to 0.693 divided by lambda equals to ln whatever it is given here, ln n0 divided by n1, and then the t half is there. T half is 0.693 divided by lambda. Basically 0.693 is nothing but ln2. So I think you all might have that how t half and lambda has the expression that ln2 divided by lambda. So I am not telling about right now that one. So just remind that t half equals to ln2 divided by lambda. So after putting this value, we can have the 7.17 meter for t half for half life of that dy 150. So do you got my point? Hello?
Yes, ma'am. I get it.